Okay, so still 11 o'clock sharp, so let's start the session. This is the Heuristic III session. So the first paper is entitled Adapting Novelty to Classical Planning as Heuristic Search, and Alexander Tuisov is presenting the paper.
Thank you. So this is a joint work with Michael, Nir, and Dany. And what we did is basically we have adapted novelty to a classical planning. So let's provide some context for this. First of all, we are talking about deterministic planning, satisficing. We are using the SAS plus formalism. And we are doing heuristic forward search. And because it is a heuristic search, we got to have some good heuristic to do it fast and efficient, right? But there's more things than just heuristic that you can use. So some search enhancers. And I want to talk about a couple of them. First of all, multiple queues. If you got some states that you want to expand and you want to choose a state, you may go by heuristic value only, but you may divide your open list into some queues of more preferable states and less preferable states to expand. And prioritize in some way the more wanted or more desired states. And second of all, I want to talk about novelty. Novelty is a neat concept that was introduced by Lipovetzky and Geffner in 2012. And what they're doing, they're saying this thing. Every state consists of some facts, right? Fact is a variable with its value. So every state consists of some facts. And you observe, while you're searching, some states, and you observe some facts in those states. And so, if there is a state, and I'm simplifying here, of course, but if you observe some state that all the facts have been previously observed, you deem this state non-novel, and you prune from the search. All right, and it was later adjusted to account for rewards in 2016. And when we adapted for rewards, we talked about notion of a base heuristic. There it was the reward function, but we had a base heuristic running on the background. So what we do in this work is basically a search enhancer. So it still requires some base heuristic to do the calculations for you. So what we did here. Previously, novelty was defined on states, right? So you've got some states that are novel and some states that are not novel. And what we want to do here is to define novelty on a fact, on a single fact rather than on a whole state. And then what we want to do is to aggregate those novelties for facts somehow to determine whether the state is novel or not novel. So how do we do that? First of all, we assign some novelty score to each fact, and we initialize it to be infinity. So consider that we've got some facts, and they're all infinity in the beginning. And then we observe a state, S1. And what we want to do is to update this novelty scores, or novelty table for the facts, to the values that we get. So we evaluate a state S1 with a base heuristic. And for example, we get the value of 5, right? So every fact that was a part of this state S1, for example, F2 and F4, gets now a novelty score of 5. So far, so good? All right. Then we observe some state S2. And we observe it with a base heuristic value of 7. And consider it has F1 and F4 as facts, among others. So F4 was previously seen with heuristic value of 5, and now it's 7. So we don't touch the novelty score. But F1, we do update the novelty score from infinity to 7. So we're just going to the minimal value. And we say that if there was some fact that its value was updated upon the upon observing the state, we say that this fact is novel. All right? So the fact that it's novel is the fact that its novelty score has gone down, and we updated it. And the base heuristic that can be derived from this is, well, let's look on the state and say it this way. If we got some fact that is novel in this state, we say that this state will be novel and will be assigned a value of 0, a heuristic value of 0 for our heuristic that we'll call HBN. Otherwise, if the state contains no novel facts, we'll say that it is not novel and we'll give it a value of 1. So basically we are opening the novel states before the non-novel ones. And we basically emulate here division into 2 queues. That's why I brought the queues in the first place. So this heuristic is not goal-aware by itself. For example, it gives the value of 0 to the initial state, right? Because we have some facts that get score less than infinity, right? And in order to deal with this, we got to break ties somehow. So we will break them by base heuristic, since we already calculated its value, so why not? And I want to do an example here. How does this work? So consider a problem with 3 variables, and the domain for each is either 1 or 0. And since we are in the middle of the search, let's consider that those are the values that we have currently in our novelty table. And so we go with our search, and we get some state S1. We evaluate it with base heuristic. We want to expand it. And we get the value of 3, right? So we look in the novelty table whether it has some novel facts or not. And we see that the z equals 1 is really a novel fact here. Previously had been seen with 5. Now we're observing it with a value of 3. And the state is novel. We expand S2. And we observe it with the base heuristic of 4. And like we did before, we observe a novel state, a novel fact, y equals 1. And so this state will be deemed novel too. And then we arrive to S3. And the base heuristic estimation for it will be equal to 2. But there are no novel facts here. You can check the x equals 1. We have seen it previously with 2. And all the other guys with 1. So this state will be non-novel. And here is the important part. Because when we got a state S3, the base estimator was less than for state S2. On the other hand, it was not novel. So by our heuristic, it will be expanded later than S2, despite having lower base heuristic value. All right? So there was another heuristic that was presented in AAAI this year, and they did something pretty similar, I would say. But instead of saving only the minimal value, they saved all the values for a given fact and deemed the state novel if it had some value that has not been seen before, regardless of it is being less or more than previously observed value. So, I've described some heuristic too, right? But, well, is it any good? Oh, yeah. So, the results are here. We were running on a bunch of IPC benchmarks, right? And we got 1,456 instances. And you can see that with base heuristics, we use 2 heuristics, FF and landmark count. This was the coverage when we are using only base heuristic. And this was the coverage when we used novelty. So we solved a little less than 200 problems more than just regular FF, and more than 50 problems more than with regular landmark count. All right, but it is not the only thing that we can do here, right? I've described only a basic way to aggregate fact novelties into state novelty. So consider the following way. I want to know, in a sense, how novel is a state. Like, okay, I deem two states novel, but I can compare between them. And the comparison will be done as follows. If a state got some novel facts, the heuristic value that we will give it is the total amount of variables minus the amount of novel facts that it has. So a state with a more novel facts will get lesser heuristic value and will be opened earlier. And if the state had no novel states, we'll check how many facts will be strictly non-novel here. And we will add the amount of strictly non-novel facts that were observed with a strictly lower value. And we'll add it to the amount of total variables, and this will be the heuristic value. So, example, as before, we got some, we are in the middle of the search, and this is our novelty table, and we open S1, we evaluate S3 as a base heuristic, and we've got total of 3 variables. And we've got one null fact. So the heuristic value here will be 3 minus 1, and it will be 2. S2, it got 2 novel facts now, and the heuristic value calculation will be total amount of variables minus the amount of novel facts, and we're here with 1. And S3, it has no novel facts, so we will add the amount of strictly non-novel facts, and there are 2 that we observed them with value of 1 before, and now we are observing S3 with the value of 2. So there are 2 non-novel facts, strictly non-novel facts, and the heuristic value will be 5. So, is it any better? Of course. And you can see the comparison here. HQB is the heuristic I just described, HBN what I described in the beginning, and you can see that there are some gains, but they are pretty modest. So the lion's share of the work was done by just differentiating between novel and non-novel states dichotomically. All right, but how do we compare to the state of the art, right? So up to now I've just talked about FF and the LM, which are, well, good, but they're pretty ancient. So we took a red-black heuristic, which is state-of-the-art heuristic, and it was used in a Mercury planner by Katz and Hoffman in 2014. And we run on the same benchmarks, and you can see that there are gains too when you use it with novelty. All right? So before that, we could improve the ancient heuristics, but now we can improve even the state of the art. All right. But there are more things that could be done. For example, before that, we broke the dichotomy between novel and non-novel states. We said, well, how novel is the state, right? But we can do the same for facts. And I won't go into detail how exactly we broke the dichotomy. We just took a fact, and based on its previously seen value and observed value now, we mapped it into more than 2 values. And, well, it did not work so well. Yes, you can see that the coverage has been reduced drastically. But there's a bright spot here. The results were very varied upon the domains. So in airport domain, we've got coverage that rose up significantly. And in the parking domain, we just totally crashed, right? We got from 20 to 6 problems solved. So you might want to ask, is there anything left to do? Well, I believe so. First of all, there are smarter ways to evaluate the fact novelty, right? So we did some mapping that I just didn't describe, but you can see it in the paper, and it's pretty basic. And I believe there are some ways to do it better. And you could also find some way to aggregate it better, right? We just aggregated, we just did the sum in our best performing heuristic, but maybe there are some ways. And here is where I think the most promise lays, is looking beyond individual facts. So nobody said that we can do it for the facts alone, right? We could do it for sets of facts, this novelty thing. And the point is that there are no known ways, at least not known to me, how to extract good sets and to do it in an efficient time. And I think this is a promising direction for future work. So, takeaway messages. First of all, novelty as a search enhancer is pretty good. It works. It works with every heuristic we've tried. And the overhead for implementing it is not that big, both in the running time and in implementing time, right? So I'm not the best programmer out there, but we managed. And 3, there is a lot more stuff to explore here. It's pretty new, and things can be done here. Thank you.
Questions? Please.
I was wondering what is the assumption behind the quantified fact novelty measure?
What's the what?
Assumption.
Assumption that if you get a fact that, well, was observed with a very high heuristic value and then you get much lower, is somehow better than a fact that got improved just a little bit. But we assumed it, and it didn't really work, so I'm not sure that this assumption is sound.
Maybe you should check it out, this assumption.
Maybe.
Yes.
Do you have an empirical comparison to the AAA heuristic that you want to go
yeah.
here?
So it was almost identical. Let me just get there. So here is the AAA heuristic, right? And we evaluate it only with FF. And here's our heuristic, and it performs really close. But it can't be just as easily improved and expanded to this one, right? So you can't just break it into more heuristic values.
Okay, so they're close and overall coverage. Is it also not by domain basis? I mean, are they confident?
Yeah, they're just performing really close, and there was not much domain difference.
No questions? I have one.
Yes.
So what happens when there are no more novel states? So everything has been seen, and so
You start to explore the non-novel.
with the base heuristic, right, or not?
No, you still run the same algorithm, but you just you just expand the non-novel state. That is, yes, the ties are broken by the base heuristic.
So basically, the behavior will be of the base heuristic.
Yeah,
right?
it falls back to the base heuristic if there are no
So this
novel
algorithm
states.
for a polynomial time, right, at the beginning, a polynomial number of steps behave differently, but afterwards it will start behaving as the original algorithm, right?
Well, that's not entirely correct, because it may fall back to the original heuristic and then discover some other novel state that will be novel again. So it will run.
Yeah, but the total number of novel states is polynomial.
Yes, that's correct.
So you have this polynomial bound, right?
It depends on the. Yes, on the.
I don't think so, right? Well, I mean, there is one version. No, because you're counting novel facts.
No, but
No.
if you improve the value by 1 every time,
Okay, yeah.
1,000.
Yeah, okay. It depends on the value of the heuristic. Yeah.
Yes.
That's polynomial, also, right?
Also the
It could be.
It could be.
And the domain of the base heuristic.
All right, so, okay, I think that we need to finish. Thank you again.